Good afternoon, everybody. My name is Jan Musiał. I'm a senior data scientist at CloudFerro, and I would like to welcome you for the webinar entitled Introduction to CREODIAS 2.0, the first commercial element of the Copernicus Data Space Ecosystem. Today with me, I have other presenters, Patryk Grzybowski, my colleague from CloudFerro. We have Uwe Marquard from TT Systems. We have Pratichhya Sharma from VITO and Andras Zlinszky from Sinergise. Apart from the presenters, we have also a support team at chat. So in case you have any questions, please do not hesitate to post the questions. So to start with agenda, I will start with the introduction to CREODIAS 2.0 with the special attention to new features, to credits for pre-commercial exploitation and research. Then I will give the description of EODATA repository, EODATA Plus repository, so the very high resolution data ordering and data discoveries APIs. And then we will move on to the commercial services of CREODIAS 2.0. So I will introduce the cloud services provided by CloudFerro. Then Uwe will introduce the cloud services of Open Telecom Cloud. Then we will hear from Andras Zlinszky the APIs of Sentinel Hub by Sinergise. And then we will have an overview of the openEO API given by Patrychhya from VITO. Then we will move on to the use cases. So the use cases will be for scientists, presented by Patryk Grzybowski, for service providers by Uwe, and then for public administration from Andreas, and for startups by Patrychhya. At the end, we will have a Q&A session and a survey. So let me start with the introduction to the CREODIAS 2.0, which is the first commercial element of the Copernicus Data Space Ecosystem. So again, why 2.0 with the CREODIAS? This is CREODIAS. It's the evolution of the former DIAS platform, so Data and Information Access Service, which was offering the Copernicus data. But now, when the CloudFerro company, who was the host, who was the owner of the CREODIAS platform, joined the Copernicus Data Space Ecosystem Consortium, now the CREODIAS platform 2.0 is the gateway to all services from all partners, namely from TT Systems, Sinergise, and VITO. And why there is this connection with the Copernicus Data Space Ecosystem? So within the Copernicus Data Space Ecosystem, all the data are for free and all the services. And if users want to upscale the services, they can go to the CREODIAS 2.0 to purchase commercial services. So two words about the Copernicus Data Space Ecosystem. I hope all of you know that the Copernicus Data Space Ecosystem will replace the current Copernicus Open Data Hubs from the 1st of November. And this will become the main access points to all Copernicus data. So Sentinel's imagery, also Copernicus contributions missions, some of the Copernicus services as well, and other data. And this is all to share the EODATA to the European public in order to generate the added value from the satellite imagery. So within the consortium, we have our prime, which is TT Systems, and then there are also CloudFerro, Sinergise, VITO, DLR, ACRI, and RHEA. So as you can see, these are the companies with a lot of experience from different sides of market, and this synergy of different experience allows us to create the largest platform of the Copernicus data. So what's the relation between the Copernicus Data Space Ecosystem and the CREODIAS? I have already mentioned that first one, it's founded by the European Union and European Space Agency. It allows self-onboarding, so the user can register by themselves. It's all the data there are for free, and there are also some of the commercial services for free, but with limited quotas based on the user types, and also there is a possibility to join the ecosystem with your services that you develop by yourself, and they will be onboarded on the platform as well. So this is the gateway not only to the services offered by the consortium, but also for other partners who would like to join the ecosystem. And on the other hand, we have this CREODIAS, which is the first element of the first commercial element of the ecosystem. And basically the services which were prototyped within the Copernicus data space can be upscaled to commercial services using the CREODIAS platform, which is now offering the services not only from the CloudFerro company, but also from test systems. So this is the cloud from the Sinergise, and VITO. These are the APIs that will be introduced later. There are flexible billing modes per pay use, and they are free credits for research and for computational exploitation, which I will also say a few words later. So now I will move on to the new features of CREODIAS 2.0. So first of all, we have a new portal with improved UX. We have the e-commerce platform where you can pay for your services. We have a new customer portal where we have merged all the functionalities which were previously a little bit displaced. So in one place, clients now have billing system, support ticketing system, and user management. And moreover, we introduced two-factor authentication to improve our platform security. So what are the core elements of the CREODIAS 2.0? Of course, this is the EODATA repository with all the Copernicus data. There is also possibility to order high resolution imagery. They are EO-based services, which will be also described later. We have cloud computing. We have knowledge base, which is the main gateway for user to get familiar with different services that are offered on the platform. So we have their described use cases and also webinars. So in case you have a question or you would like to see previous webinars, that they are available there. So the new customer portal comes with the user in one place. You can manage cloud services, billing and reporting, payments and order, invoicing and support tickets. So everything is now in the same place. And you can also configure cloud services and user profile organizations, and you can assign credentials for sub-accounts. So this allows users this gives a lot of flexibility to users to manage the services. Okay. I think yeah, there is some problem with with slides. So the new e-commerce service brings two cloud environments that can be purchased from e-commerce. This is the CloudFerro cloud WAF3, and this is the test systems OTC cloud. So you can new e-commerce allows you to select cloud providers, cloud services, to pay for these services via bank transfer or the Stripe platform, and it will allow very soon to also apply for free trials on both platforms. There are also credits for pre-commercial exploitation and research. This is what we offer to startups and for researchers in order to allow them to upscale their applications and services, and also for the common benefits of our consortium and the service provider. So how you can apply for those credits? There are, let's say, three ways. First of all, you can apply for the free credits from CloudFerro. There are 250 euro credits for the cloud computing. You can also apply for credits through the network of resources. This is the European Space Agency program devoted for the for financing the cloud computing. And also within the Copernicus Data Space Ecosystem, we have a separate budget for value creators to allow startups and service providers to move on from one cloud to another, for example, or to develop their own services using the Copernicus data. And here you have more information in the web links. So I will just give a brief introduction to the EODATA, what we have there, repository. So we have all Sentinel 1, 3, 5P, and 6 products published by European Space Agency and EUMETSAT. We have Landsat data, but only for Europe. These are the data sets provided by the European Space Agency. We have SMOS imagery, Envisat imagery. We have EcoStress data. We have selected data sets from the Copernicus services, and we have also ancillary data sets such as digital elevation models or land cover classifications. And what is also important, and this is evolution of our service, that all the data are from Sentinel, apart from Sentinel 6, are available now within the 15 minutes after the publication by the European Space Agency. So this is crucial for time-critical applications. Okay, so next slide. How to explore the data sets. So then, first of all, you can use the graphical user interface, the CREODIAS browser, which allows you to visualize and to search the data set using the criteria. But what is also different, for example, between this browser and the Copernicus Data Space Ecosystem browser, that here you have also workspace with the additional commercial processors, such as, for example, Sentinel-2 enhancer. How to explore also the EODATA repository using the APIs. So in case you would like to programmatically ask for data, you can do this using the OData and OpenSearch APIs, which are based on the, as we can see here, on the REST queries. So it's just you need to type the URL and you will get the list of data sets together with corresponding attributes. So what are the ways to access the data? So first of all, the entire EODATA repository is mounted as a folder on the virtual machines. So if you start a machine within the CREODIAS, it's already there. You can also download the data using the CREODIAS Explorer. You can download the selected files using the Zipper service or Zipper API. So you can do this also programmatically. And you can also now mount or stream the EODATA content using the S3 protocol, using the external keys. So they are very flexible way to access the data now. And what commercial EODATA are available on the CREODIAS? So we cooperate with Airbus, Planet, Axel Space, CG Satellites, KGS, and CIS with CompSat satellites. So in case you require very high resolution data for your work, we can apply or order this data for you, and they will be placed in your private S3 bucket. So regarding the commercial services of CREODIAS 2.0, I will start with the list. So first of all, we have Jupyter Hub, which is provided by CloudFerro. We have on-demand processing, so-called product generation as a service. So then, for example, you can order computation of coherence or Sentinel-1 backscatter. So the higher level products which are required for your work. You can also use the Sentinel-2 special resolution enhancers. We have also Sen4CAP image. So Sen4CAP is the system for common agriculture policy. So we offer also this as a service. We have the openEO API and Sentinel Hub APIs, which will be introduced further by my colleagues. And regarding the WAF-free cloud services, now they are based in Warsaw in Poland with the OpenStack Yoga version. So we use, as you can see, the open source software only. There is a significant increase in computing power, so now our clouds have better software, and also we were focusing now to improve the connectivity with the EODATA repository. So there are several 100 gigabit links to ensure high-speed data transfer and access. We have a region with user-friendly Kubernetes, so you can deploy scalable services. So this allows you also to manage effectively the computing resources. When there is a lot of traffic, the cloud can scale up and scale down. We have also new AMD processors, which are very competitive in terms of pricing. And we have also certificates, so security certificates, ISO and BSI, in case your application needs such a certificate. So regarding the WAF-free cloud services, they are located, let's say, in 2 locations. So one is Warsaw, there are 3 data centers there, and one is in Frankfurt. And you can, within each of these data centers, there are various flavors of virtual machines. We have dedicated servers, we have virtual machines with GPU, bare metal servers, Kubernetes, and also pre-configured virtual images with Windows, Linux, OSGeo Live, and Sen4CAP. As I was mentioning, we have storage services, HDD and SDD, object storage, and we have also backup storage if you would like to back up your infrastructure data on our cloud. We have network services such as load balancer, virtual network, and routers with firewall as a service. So regarding also the billing modes, we have pay-per-use. We have so this is a prepaid billing with credits. We have pay-as-you-go. So this is post-paid billing. So after the resources has been consumed, we just issue an invoice. We have a fixed term when you can, for a certain time, rent a machine from us. We have special discounts for contracts longer than 1 year. We have special discounts, 18% for scientific institutions. We have on each of our clouds, as I was mentioning, there's free of charge EODATA access, so to all the entire EODATA repository, and we have this 250 euro free credits for just to try the functionality of the platforms. So this is my last slide. So basically, if you would like to see the list of different flavors or and the pricing related to them, you can visit our web page. And this was all from my side. And now I will hand over to Uwe, who will tell about the cloud computing resources from the Open Telecom Cloud.
Yeah, before I jump into the presentation of the Open Telecom Cloud, just a few words regarding my person. So I'm Uwe, I'm with T-Systems, working as a key account manager in our public sector division, and I'm responsible there for the space business we actually do, and the big space programs, which are obviously Copernicus. This is why I'm here. And it's also additional programs like, for example, Galileo. So let's go into the Open Telecom Cloud. So I would like to give you a high-level overview. So we are not going into details. And if there are questions later on, feel free to ask them, and also to visit our webpage for the Open Telecom Cloud. So I think worthwhile to mention, and we are really happy that we were actually selected by the ISG provider lens as the leader in the hyperscale infrastructure and platform services for Europe. And this shows that Open Telecom Cloud is really one of the big cloud infrastructures. It offers a really broad IaaS and PaaS service, and takes into account, which is very important for us as a subsidiary of Deutsche Telekom, all the high compliance requirements which we have in Europe. So we strictly comply with the European legislation, with the data sovereignty. We have, and I will show this in a bit more detail in the next slide, really geo-redundancy implemented. And we are really the European alternative to the large hyperscalers, which probably everybody is somehow familiar with. We also have very experienced consultants, and they are always happy to take into consideration your issues, challenges, and help to actually bring your applications into the cloud. So just a few numbers which we believe are impressive. So first of all, Open Telecom Cloud is actually the biggest OpenStack cloud in Europe. And just a few figures, so which are maybe most telling. So like, for example, the data center space, we are talking more than 6,000 square meters of data center space. We are running more than 770 petabyte of storage, so which is actually data which is stored in the Open Telecom Cloud. And so 3,500 racks, which fit pretty much into a full soccer stadium, just to give you an impression of what we are talking about here. Trying to switch to the next slide. Let's hope it works. Okay, now I'm one too far here. Okay, sorry. Quite a delay. Okay, here we go. So that's, I think important to understand. We have actually three main regions. Here in the context of the CREODIAS, I think the most important regions are the German region, as well as in particular the Netherlands region. What we consider as a region is not only one data center. So each region actually consists of what we call twin core data centers, which means there are two data centers actually implemented which are far away apart, to have some really geo-redundancy already in place, but which are close enough to have a high-speed data connectivity between both, so that availability zones can actually be distributed among those locations. For the CREODIAS, most important is actually the Netherlands region, because the data repository on Open Telecom Cloud, which hosts also all the Sentinel data, is actually located in the Netherlands region. We also have a Swiss cloud, but I think it is not so important in this context here. Oops, that's not what I intended to do. Okay, next slide. Here we go, just in a nutshell. We are a European cloud, I already mentioned. So most importantly, we are GDPR compliant. We are a sovereign cloud. We have high focus on security. As Deutsche Telekom, we are also running a very big network of honeypots around the globe, actually. Deutsche Telekom is the, the biggest, largest European network provider. So we have super good network connectivity in place. And as I already pointed out, based on this twin core data center concept, we are highly reliable and can offer very high availability with our cloud services. So we also provide, or have actually, hold all the certifications which you need depending on the service you want to provide. So this starts with the security certifications. I will not go into details, but I guess 27,000 ISO certificate is probably known to most of the people here. We also have the certifications for data privacy, and even for some specific industries, we hold certifications that may be interesting for specific use cases for you. But as said, I don't go into any details here. Another important aspect, which we believe in particular when you work nowadays in the public sector environment, is sustainability. And we are really proud to say that the Open Telecom Cloud is powered with 100% electricity from renewable energies. So more than that, we actually even have a dedicated team in place which really pursues optimizations in terms of sustainability improvements. And that is something we constantly measure, and which may also be important for projects if you want to run them for public administrations on our cloud. This slide gives a very high-level overview on all the services we are actually providing. So for the benefit of time, obviously, I will not go into all those services, maybe just a few services which I want to point out, which are super interesting. These are, for example, our cloud container engine, which we call CCE, which is a managed Kubernetes cluster tool for you, which helps you to easily manage your Kubernetes cluster. We have specific network services, which I already pointed out. Highlighting, for example, is that we have tier 1 direct network connectivity via the Deutsche Telekom network. We also have high-speed connectivity to the GÉANT network. So which means if you are somewhere active in the research environment and you need research connectivity or research network connectivity, that is absolutely given for Open Telecom Cloud. And security already highlighted. And there's also higher level services like, for example, the Model Arts development platform, which supports artificial intelligence developments like machine learning features, etc. Okay, maybe as a last slide, what is very helpful for you as a user, we have those enterprise dashboards, which give you the option to really monitor your consumption on the cloud. So it shows you really at a glance what you are currently consuming and what you have consumed. You can actually customize those dashboards to help you to really manage your cloud consumption with a variety of options. You can also set thresholds to support your cost control on the cloud. I actually do not have a slide. I think it's the last one. I do not have a slide on our cost model, but we also offer obviously the typical cloud environment. You can have reserved capacity, you can have elastic capacity. We also provide the vouchers, as pointed out by Jan before, for CREODIAS. So 250 euro vouchers can easily be obtained. Those vouchers can also be extended if you request for it, depending on your use case. And we also fully support network of resources. If there are projects which you will bring on network of resources, this is fully supported by CREODIAS and obviously now also on Open Telecom Cloud. That's it from my side for the Open Telecom Cloud presentation.
Okay, thank you very much, Uwe. And now we will move on to the presentation by Andras Zlinszky from Sinergise.
Hello, everybody. My name is Andras Zlinszky. I'm community evangelist at Sinergise. I promote the use of Sinergise solutions and of Copernicus Data Space Ecosystem. Sinergise is a company focusing on making satellite data accessible. So as you will all know, the connection between satellite data sources and users is often not a trivial thing. Satellite data providers downlink the data from the satellite, they store it in their own operational data centers, and then they serve it through their own download centers or through their own data infrastructures. But to build a service that connects the data infrastructures of multiple providers and allows the data in one format that is accessible and interoperable to everyone, I think this is this has been a main challenge in remote sensing, and I think it's a game changer that we now provide solutions for this. So to allow interoperable use of various data sources, to make these data sources traceable, and to provide information that is actionable on the user side is what our mission is. We were once a startup, now we've grown to a global service provider. Our customers include intergovernmental agencies such as ESA. We are one of the main software solution providers for the Copernicus Data Space Ecosystem. We work a lot with national agencies, especially in agricultural monitoring. We also work with industry providers, for example, the real estate and insurance industry, but we are also still closely involved with startups and NGOs and education. So our flagship product is Sentinel Hub. Sentinel Hub is a set of APIs, so application programming interfaces that allow one piece of software to communicate with another piece of software. In practice, this means that when you are coding a particular software solution, you can access Earth observation data sets the way you work with normal data variables in your code. So you can pull in Sentinel imagery, Landsat imagery, commercial imagery, but also your own data that you have uploaded in the same format, auxiliary data from various international projects into this hub. And then with the APIs, you can serve it to your own code, you can serve it to web applications, you can also make it available in GIS software, or you can prepare a stack, prepare a set of data that is accessible for machine learning algorithms. Sentinel Hub connects many different data sources. A lot of them are free. So our backbone is Sentinel-2, which we serve in with atmospheric correction and without atmospheric correction, but also with our own cloud masking algorithm. We also serve Sentinel-3, both sensors, Sentinel-5P, but also older data sets such as MODIS are still available for a restricted period of time, but also Landsat. Sentinel-1 is of course also available. But in addition to this freely accessible data package, we serve Copernicus digital elevation models, cloudless mosaics, but also commercial data. So Sentinel Hub has grown to a go-to platform for sharing commercial satellite data. Often commercial providers also have difficulties in making the data very accessible, very easy to connect to via an API. And if you're not willing to dedicate yourself to one specific commercial provider, you're rather searching for a solution that allows you to interact with several ones, then Sentinel Hub is going to be your tool to access planet data, Pleiad data, spot data, worldview data. And all this functionality, which is of course available for coding, is also available in a highly accessible online browser tool. This is the Sentinel Hub EO browser, which has grown into, I think I can say that, the most popular Earth observation visualization platform globally. It has a search functionality built on the API, so you can search data based on an area of interest and a specific time slot and sensor, but also for data quality. And then you can visualize this in your browser. And this does not only include TrueColor or a couple of popular vegetation indices, but also a set of, well, nearly 100 custom scripts, specific processing applications with their own spectral index and with their own visualization. And there's also quite some capacity to customize EO browser with your own collections. You can effectively set up something like a monitoring system with a specific user of interest, area of interest, and a specific algorithm and visualization that you can return to every time you open your browser, and that allows you to track what's happening in a specific part of the world. So the browser is really the interface for educating people, for training people on Earth observation, just for looking through data, visualizing it quickly, or sharing it with third parties. But the main product is actually the system of APIs. So these APIs move Earth observation data processing from the classical workflow of downloading the data, storing it on your server, and serving it externally, to working without download. You can perform data search by area, by date, by quality. You can perform pre-processing of the data, spectral index calculation, and even zonal statistics calculation before the download. So the only thing that actually moves through the network is the result of your calculation itself. This is what you can do with the process and the catalog and statistical API. These APIs also have flavors that are designed for wide area processing. So we have batch processing APIs, asynchronous processing, batch statistical API available. And we also have an API for connecting to GIS software serving data through the OGC standard, the OGC API. So effectively, Sentinel Hub is an integration of Earth observation data access, the imagery we serve, the APIs and coding tools. We also have Python bindings. We also have processing libraries with a very vast toolkit in JavaScript and Python for performing operations on the data, and the processing capacity, which is also hosted by us on board and also available within CREODIAS. And the close fusion of these three, the data access, the APIs, and the processing capacity, is what enables a super efficient approach to data processing. And finally, just to talk a bit about our pricing or our offers. Of course, there's a free trial level. There's an exploration level for non-commercial operations and for research, but this already allows you to access a lot of the functionality. And then depending on your needs, we have basic, Enterprise S, and Enterprise L, and these offer different processing request amounts. Now, a single processing unit, just to put this in perspective, one processing unit is 6 square kilometers of Sentinel-2 data with all the bands. So, for example, the Enterprise S subscription with 400,000 processing units per month would allow you to create a complete Sentinel-2 mosaic of the whole area of Australia once a month, or to process imagery from the area of Hungary, which is 100,000 square kilometers, as they come in with 5 daily cadence. So again, depending on your needs, you can scale your services up as you go, or you can decide for a single package if you already know what you need. But these offer the integration of processing capacity and code and data access within CREODIAS. Thank you.
Okay, thank you very much, Andras. And now we move on to Patrychhya. So Patrychhya, can you share your screen, please?
Hi everyone, good afternoon. I'm Pratichhya, I'm from VITO. In VITO, we have been doing remote sensing related tasks for a couple of years or decades, and openEO specifically comes from the remote sensing service team within VITO. So in my presentation, I will be focusing about the openEO service that is available within the CREODIAS. But before moving forward, for the users who have already been using openEO platform, I would request them not to get confused with the openEO available in CREODIAS. It is simply an instance of the openEO platform itself. And moving forward to the users who are very new to openEO, it is open source software in the form of source code that allows you to easily access the data and process Earth observation data set. This openEO API allows to facilitate large-scale data handling as well. Therefore, use case can range from exploratory research to mapping, or even EO-derived maps, and also information extraction from these Earth observation data sets. Therefore, I can highlight the benefit of the openEO API as this, that it supports unified and straightforward approach to access multiple data sets and is considered to be scalable and efficient approach. Having said that, this is a standardized system that works across different platforms, so users don't have to deal with the underlying technologies and software on libraries themselves. But the best part about openEO, I would say, is that it supports fair data and open science principle. So having said that, as I mentioned earlier, that openEO is a versatile platform, so it supports multiple clients. And these clients are like Python client, R, JavaScript, and also for users who don't want to do programming or who prefer to use graphical user interface, we have web editor. That is simply a version where you can drag and drop the available process or services. And you can use the simple openEO API to directly access all the data set available in the Copernicus Data Space Ecosystem with the same workflow format using any of this client library. The idea with this, I would say, is to reach all the users from different field or different background, and to make it as simple as possible to execute the different processes that is required in case of Earth observation. In support of what I said earlier about supporting complex workflow as well as scalability, this is one of the examples that has been prepared by our openEO team using openEO. So this is a continental crop type map of Europe. In a similar way, there are several other applications that is available, such as ESA World Land Cover, that also use World Water, so that also use openEO land cover map, that also use openEO. So these are some of the examples of large-scale processing that can be done within openEO. And if to move forward, like how much free tier is available as a part within CREODIAS. So there are 1,000 credits available to each users. These credits are replenished every month. Having said that, I think it is safe to mention it here that we have been receiving a couple of requests from the users who are doing large-scale processing. So based on their request, we might increase this credit. But we request you to follow that up in the documentation for update. But at the moment, we provide you with 1,000 credits monthly. And if these credits run out, there is always an option to apply for non-subscription or even directly contact the service desk to increase your credits. That was a short description of the service of openEO that we provide within the CREODIAS.
Okay, thank you very much, Patricia. And now we will move on to the presentation of the use cases for specific target groups. So we will begin with the presentation from Patryk Grzybowski for data scientists about the air quality monitoring.
Hello, everyone. So I'm going to introduce you how to use CREODIAS data and services in respect to study about air pollution. but in fact, please keep in mind that this is an example, yeah, some general case. I believe it could be implemented in every kind of research, in fact. But what about the specific study? The objectives were to estimate nitrogen dioxide pollution over Poland using Sentinel 5P data and support national network of air pollution, especially in the places where there is no such air quality monitoring. And what exactly was done? So there was developed a model aims to estimate surface nitrogen dioxide concentration. As an input data, it was used, as I said, Sentinel 5P data, also meteorological data, some socioeconomical factors, something which I called anthropogenic data, some economic indices, etc., elevation models. And all of these data was an input to the model, machine learning models. So as you can imagine, there was terabytes of data, yeah, as an input, and it requires a lot of computing power, and this is where CREODIAS meets science, yeah, in this particular case with continuous data delivery and infrastructure. But what was done using CREODIAS? So firstly, preprocessing of data using HARP toolkit. There was thousands of images, so it was great that we can use infrastructure and continuous data delivery. Convert data, net CDFs into GeoTIFFs and COGS, extract value, create maps. All of it was done using CREODIAS. And what is the most important, train and test these machine learning models. Yeah. And why CREODIAS? As I said many times within this few minutes, 2 or 3 minutes, continuous data delivery, yeah, and constantly working processing environment, and possibility of continuous training and testing models. As Jan said, Sentinel data, also Sentinel 5P data, is provided in a few minutes after acquisition, yeah. So you can fit your model with new data as often as you wish, and you can develop your model, run your model also as often as you wish. So to sum up, why CREODIAS? The answer is on the left. Yeah, this cycle. You can input data, run code, train, test, develop model, and again you can input new data, run code, train, test, and again develop your model. So as I said at the very beginning, it's a part of all researches, yeah, not only about air quality. So I'm pretty sure that in every kind of research, every kind of science, CREODIAS in this way would be very useful. And at the end, I encourage you to visit our knowledge base and take a look on on tutorial which was prepared about processing Sentinel 5P data on air pollution using Jupyter notebooks. There is a barcode which links to this tutorial. And that's all. Thank you for your attention.
Okay, thank you very much, Patryk, and now we will move on to the presentation by Uwe.
Okay, so what I'm going to present is a use case which is called Ypsilon, actually yield prediction, and it is implemented on the Open Telecom Cloud by Vista. Vista is a company, it's a German company, actually looking or focusing on value adding on remote sensing data. They are mainly focusing on two areas, which is agriculture and hydrology. And so what I can, or what I'm intending to present to you here is the following use case. So it is actually a model which is now implemented on the Open Telecom Cloud to forecast yield, and you can do this for different crop types. The main target group for this service is actually our public authorities, but also the underlying, let's say, companies like, for example, traders, mills, seed growing companies, or even biogas plant operators. So for them, this kind of information is very useful. And this is actually the target group. It is based on state-of-the-art satellite data and actually physically based plant growth modeling. As indicated here in this diagram, it uses satellite data, it uses statistics, meteo data, forecasts, and also soil and topography data as input data, then based on knowledge, and how to actually combine this data. It delivers at the end of the day for a selected region a forecast on the yield production. This is a service which is available European-wide nowadays. What I will be mainly showing is actually focusing on Germany, because it's the service is created in a way that a customer can actually select a certain crop type. He can select a certain region, even sub-regions of Germany. Like, for example, the federal states of Germany have different, policies, etc. And then you can initiate actually a forecast. So starting the processing, and the way this is done is shown here on the next slide. So the key input data, and this is why CREODIAS plays a major role here, are Sentinel-2 data. And we are talking not only about recent data, we are actually talking about a longer history of data, because the model looks for verification and calibration into history, really years back, in order to finally come up with a forecast. And as you can imagine, that means there are quite a lot of data which have to be processed. And in terms of steps, there are various pre-processing steps, like the atmospheric correction, cloud classification, land use classification, and also the plant parameters which need to be retrieved. And this all will be put into the processing chain. That means based on the input data and all this processing which needs to be done, the data volume is actually enlarged by the factor 10. So for the German model, covering the whole of Germany, the initial Kubernetes cluster was actually based on 10 general purpose VMs on the Open Telecom Cloud, each of them with 32 CPUs. And it is capable of processing up to 300 satellite scenes. Vista actually uses the Cloud Container Engine for setting up and managing the Kubernetes cluster. They find it very useful and easy to handle, so they can actually rather focus on the real algorithms which they have to implement, rather than managing any kind of underlying infrastructure topics. Based on this commercial model, where users can actually go on the platform on order for a specific region, for a specific time, for a specific crop type, the forecast. The system supports obviously respective scaling up, depending on the magnitude of the region which is chosen. Then this system has to just enable all the underlying resources and scale up accordingly. So this is all handled on Open Telecom Cloud. And just as an example for how those data can be used, I just picked one which is very recent. So it shows actually the winter wheat in Germany. So what you can see here on the left-hand side, actually those pictures are from early this year, so May. And you could see Germany had a pretty wet springtime actually. And if you compare this, and this is shown on the right picture here, if you compare this with the average recent years, you can see that there was actually in most of the regions rather more humidity, more water available, which actually hinted into a direction that would be a good yield at the end of the day. So, but then looking at this, at the end of June, we had the very dry summer, and now you can see actually that based on this really dry summer month, the yield prediction model showed that the yield prediction will actually be decreasing. And it shows there are actually up to 17% of a decrease in the winter wheat production for certain regions in Germany. It's not everywhere the case, but it is, and that is why this kind of modeling is very helpful and very important. For certain region, it is quite dramatic, and that is what the model can actually do. And as said, CREODIAS is the ideal platform to do this. The main benefits, of course, on-demand capacity for the on-demand jobs, usage-based costs. There's no invest required because you just pay as you use. It's very good for managing the peak loads. If there are more jobs, you can increase obviously the respective resources, and Vista is able to focus on their core competencies instead of managing infrastructure issues. And it's super easy to use, and you have full availability of up-to-date geodata based on CREODIAS. Thank you. That's from my side, this use case for service providers on CREODIAS.
Okay, thank you very much, Uwe. And now we will stay with the agriculture topic, and we will follow on with the presentation from Andras about CAP monitoring system developed by Sentinel Hub.
Hello again. I'm introducing to you a case study of CAP monitoring in Slovenia in the context of monitoring solutions for government agencies. So government agencies are in many countries already starting to work with satellite data, or in some cases there are operational applications since a couple of years. If you work at regional to national scale, then your main priority is wide area monitoring, large area coverage. So you definitely need a high level of automation. Already at the start of the Sentinel program, we have seen this conclusion that most of the images we collect are never going to be visualized and checked by a human person. Most of the data will go through some sort of a machine learning algorithm, and only the conclusions will be examined by scientists or operators or practitioners. But we have to be able to identify the uncertain cases where the algorithm is not sure, and these should be labeled and forwarded to operators. So this is the paradigm that government monitoring agencies can use in this big data case, and CAP monitoring is one of the most prominent of these. For those of you who are not really familiar with CAP, CAP stands for Common Agricultural Policy. So it is the main instrument of the European Union subsidizing farming in Europe. It's also more than 30% of the European Union annual budget. So there's a lot of money going through it, which means that, of course, compliance to the rules has to be monitored really, really closely. I think that at the moment, CAP monitoring is the largest civilian application of satellite data worldwide. Every single agricultural parcel in the European Union is being checked regularly with satellite data to assess the compliance of the farmers to their claims. So farmers submit a claim where they describe the crops they are growing and maybe the sowing and the harvesting times and the specific subsidies they want to request. And these are followed up by the monitoring and the control, where there's three possible outputs essentially in this so-called traffic light scheme. Red means it's confirmed that the parcel is non-compliant. Yellow means that the parcel is confirmed to be uncertain. So we have to forward it to an operator or someone has to check it. And green means that the parcel is confirmed to be okay, so that there's no further check necessary. In case specifically for Slovenia, CAP monitoring is also carried out by satellite monitoring since quite a while. Slovenia has a continental climate. About 50% of the satellite acquisitions are cloudy, mostly due to the mountains. The main crop is grasslands, but cereals, industry plants, fodder crops, vines, and orchards are also involved. And specific to this country and to the Central European region is that small and narrow parcels are really abundant. And I'll tell you in a couple of minutes about how this problem was solved. So this monitoring is carried out using the Sentinel Hub API pack. So the data preparation for the national runs works through the catalog API. You can request for a specific area of interest all the imagery that is available. And then after this catalog is provided, the process API is going to do the cloud masking and the outlier detection, but not just this, but also the calculation of spectral indices, such as bare soil index and NDVI or red edge NDVI. And then once you have a data set of these indices, you don't stop there. You calculate the parcel level statistics with the statistical API, so the mean, the standard deviation, the minimum, the maximum for all these values. And we're still on the server side. This is where actually the download occurs. So this means that the data volume is reduced from billions of pixels, several repetitions, of course, of the image collection to 1 million parcels and the time series for these parcels as a database. And then once we have this data set of spectral index time series, it's possible to define markers that are signals for a specific process. So the first thing you want to check in CAP monitoring is homogeneity. Is the parcel as claimed by the farmer a single unit? Is there a one-to-one match between the outline of the parcel from the satellite pixels and the outline that has been claimed by the farmer? If this is correct, if the parcel is a homogeneous unit, then it can be forwarded to further checks. And this is queried using the standard deviation of the vegetation index time series. If it's not homogeneous, you expect, of course, a large standard deviation. If it's homogeneous, then you expect most of the pixels to have approximately the same time series. And then, based on this spectral index time series, you can check further markers. Minimum agricultural activity. So is the plot farmed? If it's farmed, you will expect that the mean NDVI for the season will correspond to vegetation, not to bare soil or water. So this is the next step to check minimum activity. And then in this NDVI time series, you can recognize local minima and local maxima, these pairs, and mowing, which is an essential element of CAP monitoring for grasslands, is recognized by checking the up and down step during these local minima and maxima pairs. So with these, if the difference between the NDVI minimum and maximum in a certain time range is above a threshold, then you can confirm that mowing has happened and the farmer is clear. And with a similar approach, there's also a bare soil marker. This identifies bare soil events such as plowing or sowing, and also serves as a proxy of cultivation. So these are checked specifically to the crop claim to see if they follow the requirements. And then certain crop groups are also identified, but this is not done using a classical a classification approach that many crop identification procedures use, because a very simple and robust approach was actually designed based on similarity. So for a certain crop, you expect the parcels to be similar to each other within a neighborhood. And then instead of applying something like a random forest algorithm, you can actually evaluate whether a single parcel is similar to its neighbors that also claim the same crop. So for this, within small neighborhoods, we create mean and standard deviation time series for each parcel that belongs to a specific crop. And then for the target feature of interest, the one we are just trying to control, we look whether it is within the standard deviation or how the differences to the mean vary during the year. And that will allow us to check whether this parcel is similar to that crop or whether it's more similar to a different crop. So this is a very, very fast and very robust approach because it doesn't require training a model. It's really just based on similarities and similarity thresholds. The problem of small parcels is really severe in Slovenia. So more than 20% of the parcels are actually smaller than 1 Sentinel-2 pixel. And for these cases, we used high-resolution planet fusion data, which was also available in Sentinel Hub and accessible through the same APIs. And the marker calculation, the same markers, mowing, plowing, similarity, homogeneity were successfully calculated on the planet fusion data. This is just an example. On the left-hand side, you see the Sentinel-2A image, and on the right-hand side, you see the planet fusion data. So for these specific cases of small and narrow parcels, there's just a lot more resolution in there with Planet Fusion, and that was successfully integrated. So in practice, these processing runs were performed every 2 weeks operationally, and this took about 20 hours for signal processing, 3 hours of GPU training for the phases that involved the model, and 200 hours of CPU time, which were like 3 hours on a 60-core virtual machine. So this is really not a lot of processing time for more than 1 million parcels and covering a whole country. This is sufficient for regular repetitions in order to allow notifying the farmers on time about compliance or non-compliance. In the end, we found that 98% of the parcels were correct. 1% were forwarded for further checks, and in 1% in the rest of the cases, some sort of anomaly was detected. So this was how CAP monitoring was performed in Slovenia in 2022 using Sentinel Hub APIs. Thank you.
Okay, thank you very much, Andras, for this very interesting presentation. And now we will move on to the last presentation by Patrychhya for startups.
Thank you, Jan. So, yeah. So before, yes, I think I should do this. So my presentation would be slightly different to the other use case that has been presented so far, because in openEO, yes, we can also, as I already mentioned, we can also do several applications related to remote sensing, as the one that was mentioned earlier, that was crop type map. But in this case, we thought it would be more interesting to show you how each individual or organization can be a part of this CREODIAS. And that would be through openEO. One of the methods is, with openEO Algorithm Plaza. We gave it a name as One-Stop Shop. So openEO Algorithm Plaza is basically a centralized platform that will host different services for EO-related applications. It can range from a very small basic services to calculating, such as calculating indices. As you can see, there are a couple of services already available in this screen, such as NDVI, NDWI, to a very complex service such as crop type classification that would predict a crop type for a given polygon. So this service can range to, as I said, very, very simple to very complex, and each individual as well as organization can provide this service in this platform. This would mostly, the main idea of this platform is to support reusability. So along with reusability, I think it would also be an exposure for a startup who want to share it to a wider audience. And yeah, and it is, as I already said, it is one-stop shop. It is not only for publishing, but also using already available services. But if we start with the publishing part, so I would like to highlight this fact that at the moment in openEO Algorithm Plaza, we only support openEO as orchestrator. So each of the service that you develop, it can be in any client library, as I mentioned earlier. However, it has to be deployed or saved as a user-defined process within openEO. And then you can come and publish your service in the Algorithm Plaza. It is not restricted to anyone. Every individual users can publish their service. If you don't want to publish the service but only use the service that is already available there, then you can also do that. One of the example that I showed here is CROPSAR, which is very widely used service at the moment. So this service provides augmented Sentinel-1 and Sentinel-2 indices for vegetations, and this has been widely used. But there can be sometimes that two different user or two different organizations publish the similar kind of service. Suppose if it can be two different variability maps, how would a user who want to use the service differentiate that? Would be based on the labels that would be provided to them. At the moment, we have defined 5 different labels, operational being at the highest, and prototype being a simple label, simple service that you just want to advertise or without fulfilling most of the criteria. These criteria are already defined, and each service are checked under this matrix of whether they qualify for being any of these labels or not. If they are basic simple service and just a prototype, they can also be available in the EO Plaza. The best part, I think, for the startups is that within openEO Algorithm Plaza, there is a functionality of reporting. So you don't have to yourself create a separate database managing about the services, how much credit was used for your service, or how many times it was executed. So similar kind of information can already be managed within the openEO Algorithm Plaza, and this can already be a very useful point for a startup who don't want to build a separate platform for this kind of features. Additionally, yes, there can be multiple individuals within an organization, and they can work in as a team. There is no limit to how many members should be there within an organization. That is possible within this platform. So you don't have to yourself manage another platform to give access to all these individuals to manage the service. That would be all for the openEO Algorithm Plaza in this case.
Okay. Thank you very much, Patricia, for your presentation. And now just to close our webinar today. Thank you very much for participation in our webinar. Bye-bye.